Hello, this is Gupta from Cheenta. Today, we will talk about a very interesting number theory problem. If you are preparing for IOQM, AMC 10 and 12, or similar mathematical Olympiads like University of Waterloo contests, this is a very nice problem that you can try it on your own and then follow with me along with this video. Okay, so grab a pen and paper and let's get started. We have 8n plus 4 consecutive integers. The problem says, if you take 8n plus 4 consecutive integers, add them up, the sum will never be a perfect square. So what is 8n plus 4? So let me first break it down for you, what the problem means. So suppose n is equal to 2. So let's break it down and understand it piece by piece. Suppose n is equals to 2, then 8n plus 4 is equals to 20. 8 times 2 is 16 plus 4 is 20. Now you take any 20 consecutive positive integers. So suppose you start with, let's say you start with 5. Okay, so you do 5, 6, 5, 6, 7, 8, like this, and you go ahead and take 20 of them. You take 20 of them. So 5 plus 20, that's up to 24 because you're including 5, right? So up to 24. So you take all these numbers and you add them up. The claim is that this sum is not a perfect square. Now you can do this with a different n and a different starting number. So the claim really is for any n. So you can, for example, plug in n equals to 12 instead of 2. You can do 10 equals to 12 and any starting number. So you don't have to really start with 5. You can start with 18. You can start with 223, whatever. It's up to you. So any starting number, example 223. So you start with 223 and 223, 224, 225, you go up to 8n plus 4. Here in our example, n is equals to 12. So that's 100. 8 times 12 plus 4 is 100. You go up to 322. The claim is, now if you add up all of these numbers, the sum will not be a perfect square. That's the claim. So how can we go ahead and prove this claim? That's the question. Sum of 8n plus 4 consecutive integers cannot be a perfect square. Okay, so now that we understand the question, let us go ahead and try and solve it. So here is how to solve it. How to solve this question. So suppose the first number is a plus 1. So the question indicates that these are positive integers. So that's why I took a plus 1, because a can be 0. Then we have a plus 1 is a positive integer. So suppose the first number is a plus 1, and then we will algebraize the entire statement. So 8n plus 4 numbers. 8n plus 4 numbers. So what is the sum of 8n plus 4 numbers? A plus 1, a plus 2, it goes up to 8a plus 8n plus 4, right? This many numbers. So these are the numbers that I want to add up, starting from a plus 1, a plus 2 up to a plus 8n plus 1, 8n plus 4. So that's how I add it up. Now, what is the sum? What is the sum of this particular thing? Well, this is basically an arithmetic progression with a common difference of 1. So you can find the sum of this. You can sort of take all the a's on one side. So you have 8n plus 4 a's, because that many a's are there, right? That many a's are there, starting from 8n plus a plus 1, a plus 2 up to a plus 8n plus 4. Plus you have the sum of the natural numbers. So that comes out to be 8n plus 4 times a plus 8n plus 4 times 8n plus 5 divided by 2. 8n plus 4, 8n plus 5 divided by 2. Okay, so I can take a 8n plus 4 by 2 common, and I have 2a plus 8n plus 5 divided by 2. Sorry, I have already taken the divided by 2 common, so that's fine. Now let's do this. This is equal to 2 times 4n plus 2, right, divided by 2. So these two will cancel, times 2a plus 8n plus 5. 2a plus 8n plus 5. Okay, now see, there is something very nice about this. This is 2 times 2n plus 1, and this is 2 times a plus 4n plus 5. So this is 2 times, this is odd, and this is also odd. So 2 times odd is 2 times odd. So can this thing be a perfect square? It's divisible by 2, but since its structure is 2 times odd, it's not divisible by 4. It's divisible by 2, but not divisible by 4. But if it was a perfect square, it had to be divisible by both 2 and 4. You see what happened there, right? So that's why this entire sum is not a perfect square. So we use really two things in this particular solution. First, we algebraize the entire formula and then use the AP formula, the sum of consecutive numbers formula. And then we also observed that a perfect square is always divisible by 4 if it's divisible by 2. If it's an even perfect square, which it is, 2 times odd is even, if it's an even perfect square, it has to be divisible by 4, which in this case it is not. It's a very sweet little problem which uses some elementary divisibility properties, and there you go. So let me know if you have any comments or ideas. I hope you're working really hard for IOQM, AMC 10 and 12 and other contests. If you are an internal student at Cheenta, please attend the 5 problem solving classes every week. We had such a great success last year only because the students attended those extra sessions. All the best and keep on doing great mathematics. I'll see you in the next one. Okay.